No problem. Sounds good. Hi, everyone. Welcome. Come on in. We'll get started here in a momentito. Okay, great. It is the top of the hour once again. Welcome, everybody. My name is Alan Barr. I'm with COEH Northern California. And on behalf of the NIOSH supported education and research centers throughout the country, we're pleased to bring you another installment of the 2026 ERC Ergonomics webinar series, where we offer free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide you access to current research supported through NIOSH ERC programs. Thank you all very much for joining us today. If you logged in with your registration email, you will receive a link to an evaluation form that'll qualify you for a certificate of completion worth one continuing education contact hour.
Alan, somebody commented that you're echoing. I'm not hearing an echo, but I don't know if others are. But I did
Mm,
want to mention
okay,
that.
thank you. Yes, is anyone else hearing an echo? Yeah, okay, so thank you. Apologies to Miriam, but it might be on your end. Um, Let me continue. Um, okay, so we have a couple of webinars coming up. The next will be on the 27th of May. Art Mimics Life when gig work realities hit the silver screen. And then the next, I think, Ergo webinar is in September 16th, using sensors to understand performance and safety in healthcare. There are smattering of other webinars in between, and I encourage you to go and check out our webinar page. You can see that at coeh.berkeley.edu/webinars, and I will post that in the chat just in case. For today's webinar, as usual, if you'd like to ask a question, please drop it into the Q&A rather than the chat. It's just a little more organized. We'll save some time at the end of the presentation to address your questions. The webinar today is being recorded, and it'll be made available along with past webinars on the COEH Northern California YouTube channel. And in support of our work, we'd ask that you take a moment to like and subscribe to our channel, help support the work. A PDF of the presentation can be requested directly from coehce@berkeley.edu, and I'll drop that one in the chat at some point also. So for today's webinar, titled Still Human-Centered, Wearable Technology in the Age of AI. And our speaker today is Dr. Missie Smith. Dr. Smith is currently an assistant professor of industrial and systems engineering at Auburn University, where she directs the Cognitive Engineering and Context Lab. Her research lies at the intersection of engineering, design, and public policy, with applications to the safe use of augmented reality technologies in domains such as automotive, aviation, and consumer goods. I'm very excited to hear today's talk. And with that, I will hand the mic over to Dr. Smith.
Thank you. And can you hear me okay?
Yes, perfect. Thank you for asking.
All righty. For sure. Well, I'll go ahead and get started. And thanks for the kind introduction. So my talk is, as you said, still human-centered, wearable technology in the age of AI. And while I'm at Auburn University, I have previous experience working at Reality Labs. Before that, I was in Michigan at Oakland University. And this talk is kind of the culmination of my experiences across those different institutions and in different roles. And so I'll just dive into it. Let's get going. Okay. So you could kind of characterize across all of those experiences, my work is really focused on human-centered design across the full life cycle of technology. And I've spent an extensive amount of time in wearables and immersive systems. And so a lot of this like comfort, wearability, and sustained use research was done while I was at Meta. But also I kind of got my start when I was a PhD student focusing on visual attention in AR and head-up displays. I also have experiencing human computer interaction. And so most of the research that I do somehow relates to attention workload and decision making. And you'll definitely see that influence a little later in the presentation. Um, but throughout all of the work that I've done, there's kind of this core of interacting within or with safety critical systems or in safety critical environments. And I'm also passionate about having real world impact with the work that I do. So I've got industry deployment for the research that I've done through the automotive industries and also through working with some consumer technology companies. And also focusing on identifying the gaps between what we do in research, but then those real product decisions where it's internal to a company, and then also how we regulate that technology. And so I'm really interested in that intersection because I think that is sometimes missing. It's easy to really focus on one, but often we don't do a good job of connecting across. And this matters because, especially in my research area, wearable technology has changed the nature of human computer interaction and human factors because previously when we're thinking especially in classic human computer interaction mindset, you have this human input output loop, and on one side you have people giving information to a system, and it may be through controls and inputs. It could be through a device like a watch or gaze input or voice input now. And then those displays give information back to the user. So it might be through haptic feeling, that's what the finger signals there, through some kind of visual display like an immersive technology, or through audio output. And there also could be other types of output, but we kind of think about it as a loop. And traditionally, human computer interaction approaches have assumed that there's this discrete interaction and users are stationary, so they're kind of sitting in one place using that technology because historically the technology was, heavy and hard to move around. Um, and there were also these clear input output loops. So what was a control versus what was a display? So control being how the human gives input to the system, and the display how the system gives feedback back to the human. Those things were very, very clear. And um, as things have evolved, as technology has moved forward, wearables are moving interaction into activity that the human does. And so what's happening is we're really changing that, as I said before, changing the nature of HCI. So instead of a loop, we could almost think of it, I like to think of it like layers. So instead of this loop where there's a clear definition between displays and controls, we have the physical world, and you've got the human in the physical world, and all of those traditional and novel forms of control or input. And then everything else that's in the world. So I like to crochet. So there's no crochet hook icon that I had found, but knitting's close enough. But also, other distractions in the world like radio or just general sounds. And then other things. So I mentioned safety critical environments. What are the hazards that are in the physical world? All of that is with the person and those controls and inputs. But what we're doing is we're adding a digital layer. And so we're taking what exists already and then we're adding to it. So now that display is a part of the world, or it's embedded into the world. Um, and we have all of the display output that the human receives from the system. And so instead of it being this neat little loop that's easy to separate, um, we're layering things on top. And so it becomes a more complex kind of system because now there's not that separation. And so as a result of that, interaction becomes continuous, very context dependent, and then also embedded into the world. And so you can't neatly decouple these things. You have to consider it all in kind of one as a single unit. Because also you have to account for the fact that the information that the person's receiving from the world or from technology in some form, from those wearable devices, they're competing for attention. And people, as we know, have limited perceptual and cognitive resources, and there's not a clean boundary to separate out, how those resources are being allocated. And so when it comes to wearables, the context of the person becomes the interface that we need to start thinking about. And that's a real shift in how we think about technology generally, but certainly with how people are using technology in their environment. The other thing, and this is where I get really excited, wearable technology affects how people think. And so, if anybody's familiar with Wiccan's human information processing model, that's what I'm about to walk through. So, if you have prior exposure to that, that'll certainly help you follow along. But if not, I'll just kind of briefly walk through it. But you could imagine if we're thinking about, how a person processes information, you have some kind of stimulus or stimuli in the environment, and those are processed by the senses that we have. So traditionally, you can think about, sight, sound, hearing, taste, and touch. So those are the external sensors that we need to be thinking about, or that are kind of collecting data. They're processing all of these stimuli, all of the signals that we're receiving from the world around us. And now remember, that's not just the real world, but that's also that digital overlay of content that we're adding through our wearable devices. We receive a lot of signals, but we don't perceive all of them. And so that's why we have many arrows, and then it's, narrows down to just one, because we perceive far less than we can sense. And that's just because the volume of information is so huge that we can't process it all. So we have to narrow it down somewhere. And we take all of those signals once we perceive them, and we think about them. So this is where cognition comes into play. So thinking, decision making, you're using your working memory to essentially kind of figure out what to do with this information that you've perceived. You might pull content from long-term memory as you're deciding what to do with it. And then the next step is basically deciding what to do with it. So selecting a response and then executing that response. And as you do that, as a person is sensing, perceiving, thinking, retrieving from memory, and then responding, they're going to potentially change something in the environment. And so that's going to give them some kind of feedback. And that becomes stimuli that updates, what exactly is happening in their world. And so this is the loop that's, continuous. And so it's not discrete. Like, it's not like we're only perceiving for a moment and then we're thinking. But we're always doing all of these things. And so it's constantly updating. And then across all of this, our attention is limited, as I mentioned earlier. And that's kind of modulating how we're emphasizing what we are, what we're sensing, what we're capable of sensing, and what we're perceiving and thinking about, and then also how we're responding. So this is a loop that's kind of always happening in all of these stages, and it's all modulated by the available attention. So these resources, your attentional resources, are limited and they're context dependent. So it's not infinite. You have to kind of choose where you're attending. And also the context that you're in changes how you attend to different types of information. So that has an effect as well. And so one of the things that my background, I mentioned immersive technology like augmented reality. One of the things that I've focused a lot on is trying to understand a little more deeply, not just how this technology can be used, because there's a lot of work in that space of, what could we use augmented reality for? And when I say augmented reality, I think of it as a continuum where essentially it could be a little bit of digital content overlaid onto our visual field, from fully immersing us in and providing not just visual feedback, but also audio and haptic and other. All of that together could be really immersive in what some people might call virtual reality. But essentially, I'm talking about for this talk, and when I mention AR, I'm focusing on that part where we have a lot of the real world that we can see and attend to, but we also have digital content that's overlaid onto it. And so the paper that I'm referencing is really focused on understanding specifically for AR, how does that wearable technology affect how people think? And so we can think about this. We can actually use this framework, the human information processing model, as a way to think about that. Because if we have virtual content like AR overlaid on top of the real world, it affects our ability to sense and perceive, because that digital content, if we can see the digital content, then we can't see what's behind it. And so it can actually block out and make it so that we're unable to sense some things in the real world because they're blocked by this digital content. So that can affect visibility and your ability to sense, but also because it is perceived separately, and there's some research that's shown that, um, it also, can may have a different level of salience, and so it may take on, or it may be more visible or more likely to elicit someone's attention and to get them to focus on it. And so it can actually affect these stages of human information processing in a really unique way that we actually don't have, historically, we haven't been exposed to. When we're thinking about that intersection between attentional resources and perception, it can also affect how people prioritize those attentional resources because, something pops into your field of view, you might either explicitly or unintentionally kind of prioritize it over other content, and so pay more attention to it. And even if you don't want to pay attention to it, the fact that it pops into your view might interrupt your thinking or change how you're attending to other information. And kind of moving on to the other side, or further along in the human information processing model, um, that cognition component is affected by things like automation, and so it can actually change. If it's automating content or providing recommendations, again, it may cause you to unintentionally respond, because now you're constraining your thinking, or you're not thinking of other options because it's provided a recommendation to you. Um, and so the whole point of this slide is just to kind of make the argument that wearable technology, and particularly augmented reality, uniquely affects how people think in ways that we know are important, but often we think about them in isolation rather than considering that broader continuum of how it all connects together. Um, because it is layered on top of the real world. It's not just affecting, one kind of task. Usually we have other tasks that are ongoing. Um, and so for AR, the design choices even can change the information processing demands. And so I'll give a little more of an example here to lay that out a little bit. So when we're talking about augmented reality displays, we can design them in different ways. So we can overlay content onto the world. So this is an example of driving, and you have this arrow that's just kind of placed onto the windshield that tells you you're going to turn left. That's one way that we could use AR, where it's just kind of overlaid. We could also localize AR, where we're using it to identify something in the real world. So there's like, a really fake looking icon that's basically pointing to your destination. So you're using like a digital cue to point to something real in the physical world. I'd call that localized AR, where it doesn't look like it's part of the world, but it's just kind of showing you something or providing information about something that's in the world. And then integrated AR is something, and again, these could be a lot of different things, but in a driving context, it could be overlaying an arrow onto the world where you're following it, kind of like you're following the yellow brick road, except in this case, it's purple. Um, but that integrated AR looks like it's part of the world. And so each of these are navigation signals. And I would argue you could probably come up with comparable versions of this for other types of tasks as well. But the way that they're conveying information is fundamentally different, even though they're all AR. And so, even within this technology, that wearable technology, how it's designed can really change what's required of people. And it can also kind of elicit these unique challenges. So, thinking about the human information processing model that I showed before, um, and we'll go through a couple of challenges or a few challenges that are kind of distinct across these different designs. So, one of the challenges is the field of view. And this is what this is getting to is essentially visibility. Like, can a person see the information? And so for an AR overlay, if it's on someone's glasses, that information is always visible. They can see it whenever they want, unless like for the glasses don't have it on anymore. But if it's present in the world, it's visible to the person. Um, where for localized AR and integrated AR, the information could be out of view. So for the localized AR, if this person needs to take a left and so they take a left, the location that's on this image in the middle, so this location right here, is not actually going to be visible through the front windshield, because if they take a left, it's going to be out the side of the car. And so essentially the whole point here is that like that information is tied to the world, and therefore if they're looking away from that position in the world, they're not going to see that content anymore. And the same for integrated AR. Or in this case, if it's showing a yellow brick road kind of thing, then what they can't see is the arrow at the end. Like there is no arrow for them to look at because the arrow is flat on the ground and far away. Then depth cues would be another thing. So one of the big issues that's pretty well studied with augmented reality and also virtual reality is that we are not, it doesn't usually align with the physical world. And so perceptually, it looks like the content is not aligned with where it should be in the physical world. For something like an overlay where there's no connection to the world and it's just kind of present on a pair of glasses or present on the windshield, it doesn't matter. There's no point or there's no need for depth matching because it's a totally separate um, like image that's processed separately. For localized AR, remember you have these like fake looking graphics that are overlaid onto the world and tied to a certain location. That's where the perceptual mismatch may be noticeable, but it's not until it's integrated that I think the perceptual mismatch will really cause confusion, because that's where it really matters. Because if it's supposed to look like it's part of the world and then it's not perfectly lined up with the world, it's a little harder to parse. Other things that we've studied some are things like brightness and color. And so we know that AR, how we're doing AR right now, especially for glasses that are see-through, there are some challenges with visibility and legibility, and so that can affect people's performance on different kinds of tasks. But that's really more about like task performance and can you see it clearly? Can you read the words clearly? Integrated AR, where it's supposed to look like it's a part of the world, could actually cause confusion. And I think the best example of this is imagining if I had a virtual stop sign that should be red and it's a really familiar kind of image, and people around the world can know, even if they can't read the word stop, they know that that means stop. But if you have a red stop sign over a blue background and it starts to look purple, it might cause confusion because people might have to like think a little harder to understand, oh, it's supposed to be red, but because of what's behind it, it looks a little different. Because we know that there are issues with color blending. And so it can actually cause confusion, which can have implications for performance. Another well-studied issue, and something we've thought a lot about, is things like clutter and occlusion. So earlier I mentioned that the AR graphics could block something behind it. That's what occlusion is. And just inherently, if we're overlaying content of any format onto the world, it's adding clutter because it's adding content on top of a world that has a lot of content in it already, so much that we're not even already processing the real world. We're processing pieces of it. But for localized AR, because you can look away from the graphics, I would argue the clutter level is reduced because it's not always cluttering your vision. Because some of it is, it can be behind you if you just look away from it. And then finally, with integrated AR, because the interfaces can also be occluded by the world. So even in this picture, you can see that the steering wheel occludes or it blocks the AR graphic. So there's a chance that it actually has lowest clutter because integrated AR can actually be blocked by the real world, and you can look away from it if you want to. So the whole point of this slide is just to show that even though all of these different forms of augmented reality they're like the same kind of class of technology, they're augmented reality, they're still eliciting different types of thinking, different types of information processing, and different demands on the person. So there's no universally best AR display. And the reason I put this in here is because I think as we're thinking about wearable technology, we're also often kind of lumping it into a group. But even within this group, you pick just one type of wearable technology, And there's really different kinds of implications based on the context of use, where they're using it, but also what it's, how it's designed and what it's designed to do. And so it's kind of the key point here is just really thinking in the weeds and in depth about, what exactly are the parameters that are they're in scope as you're thinking about wearable technology and how we design it. Um, Taking a step back, because we were really in the weeds there, users are already at capacity. And I've mentioned this before when talking about like just the information that we're capable of perceiving from the world, because we already can't perceive all of the information that's out there. And that's because people are multitasking, so they're often doing multiple things. Even simple things like driving and listening to music, you're still multitasking, or walking and talking is still multitasking. We're also managing fragmented attention, and some of this is because of the wearable devices that we already have. Um, and because wearable devices are letting us move around while we are interacting with different technology, we're interacting with this dynamic external environment. So we're not stationary as we're moving around. And so those resources that I mentioned earlier, in the human information processing model, those are limited. And wearable systems are competing for that limited perceptual and cognitive resource supply. So we need to be really cognizant of that as we're thinking about, the design of wearable devices and how they're used and how they should be used. So, kind of going back to the title of this talk, it includes artificial intelligence, and this is where I think AI can really change the game for wearable devices because it does enable adaptation for user needs, and so it can start to account for um, some of that movement through this dynamic environment that can be safety critical while people are multitasking. And that's because it can help select like what is the information content that actually makes it through to the user, or what's the optimal modality. So are we using vision, or I've talked a lot about vision, but are we using auditory cues or haptic signals, vibrations or squeezes or something like that. But also thinking about presentation timing. So AI can adapt when information appears so that not only is it the right information in the right format, but it's coming at a time when it's not disruptive or problematic for people. And so that adaptation redistributes the cognitive work that's happening. So um, it kind of actually makes it more complex, but also really interesting because we know that adaptive AI can reduce overload, and that's because it can adjust salience. So maybe it reduces the brightness of a screen that's really not necessary, so you can focus on something that is. Or if there's an urgent alert, it can help you identify that more quickly and pinpoint the cause of it more quickly. AI could also potentially help switch modalities dynamically. So if your visual field is overloaded and you need to switch to a different modality, it can support that potentially by redistributing that work so that you're relying on hearing instead of vision. But it can also create new interruptions. And part of this is because, there's benefits to switching between different modalities, but also if they're unexpected, that can be potentially problematic because our perceptual system is predictive. And so if you're expecting something to come as an audio cue and it comes as a visual cue, people may miss it or they may be slower to respond. There's also a pretty well established uneven cost of switching modalities. And so going from hearing to vision, I think, is a higher cost, that shift, than just staying in a vision scenario, because switching back and forth, there's a little bit of expectancy, but even just the switch itself can be challenging because you're having to process, initially one signal and then another kind. Um, What's a little less studied is the impact of noisy environments. And what I mean by noisy, it's in quotes because it's not just loud, but also when it's, a suboptimal environment or a suboptimal cue. And so that's not as well understood. So we do know that for a really clear signal, there's a cost of shifting, but we're not sure as much about that shift when it's in a noisy environment. And so this is some research, some prior work. This was a poster that we presented at the Human Factors and Ergonomics Society annual meeting. But we really keyed in on this. So we wanted to learn a little more about how adaptations and adaptive AI could impact the cost of switching, or positively or negatively, when modality changes were unexpected, and then trying to figure out what that cost was and also how noise affected the cost. So I'm just going to explain the design of this a little bit. So what this graphic is showing is on that kind of bottom row, you see some ears and an eye. And so basically, if you imagine the task that a person was trying to do is identify, is this a word or not a word? So ash is a word, cow is a word, oif and prosk are not words, but log is. So essentially, a person was differentiating what's a word and not. And then they were doing it using different modalities. And so in this instance, you can see they started out hearing the word ash and then seeing the word cow. So they were shifting from hearing to vision. And then again, back to hearing. And they stayed with hearing for the remainder of this little example. So this was the task that people were doing. So it's a pretty simple task, a really like psychophysical type response time study. And the other thing that we did was we also provided context. And so we said, okay, in this set of tasks, you should expect like most of what you're going to get is going to be an auditory response. So you'll need to like be listening for it. Then, so that was 80% auditory when we told them that it was going to be mostly auditory, and then 20% visual. Then we had a scenario where they should expect visual. And so that was 20% auditory, 80% visual. And then we had a split attention where it was just 50-50. And so what we found was that the higher expectancy increased the cost of switching away from the audio modality. So when we told them to expect auditory, as compared to when it was split between just 50-50 between visual and auditory, there was a higher cost. So, and just to explain this graph a little bit, I think I have 3 sets of graphs. The y-axis is their response time. And so essentially that's how long it took for them to respond and identify what actually, whether it was hearing or whether it was a word or not, regardless of the modality. And so the switch, the yellow line that says switch, is showing that when they were switching, there was a higher cost when they expected, and then it was lower when it was split. And then when there was no switch, it was lower when they expected auditory for the auditory signals because they were expecting it and it was in the modality that they expected. And I think there was no significant difference for that split condition when they were not switching between them. So there actually was like an impact of expectancy on their ability to perform the task and how quickly they could perform it. So that's what we're calling a higher cost of switching. And so again, the more they expected one type of signal, I would say the harder it was for them to respond, or the slower they responded when they weren't expecting that signal. So when their expectancy didn't align with what signal they got. And this is important and significant because adaptive systems often, we're simplifying human thinking for adaptive systems when they're kind of predicting how we should adapt to a human. They may treat modality switching as like an optimization, but for users, a switch could be an interruption because if they're not expecting it and they can't predict always reliably what the system views as optimal, because some of how we think is not always rational. And so there can be this disconnect between, if that switch is unexpected, whether or not they should have expected it, there may be an additional cost that we have to account for in how we're designing these adaptive systems. The other thing we looked into is modality. And so we know modality matters, and you can already see it just in going from the response time um, from seeing to hearing and then from hearing to seeing. So both were significant, but there was a lower cost going from they heard it to they saw it to hear it, from when they were hearing and then they saw it. And so again, we have the switch and no switch on the response time is on the y-axis here, and then switching and not switching is on the x-axis. But again, there's a higher, so that higher cost is important to think about because we also know like different modalities are going to have different costs when they're switching. So not only are they going to be like absolutely different because if you're hearing, you have to, and this is why, so if you look at this, the shift was from on the top one, the shift was from seeing to hearing. The reason this is so much higher, it's almost a second average response time across both conditions as compared to the bottom where they were seeing. It's a little less than a second, about 0.65 to zero point 0.7 seconds. It's because it across it's specifically takes longer to respond to a an audio cue because you actually have to hear the whole cue and wait for it to finish, and that takes time as opposed to reading something. And these were really short words or non-words, so it was a really quick thing to check. So there's an absolute difference between a heard cue versus a seen cue, but also the cost of switching is different based on so a switch would be more costly than not switching. And then the final thing we looked at was expectancy. And so we found that higher expectancy increased the cost of switching away from audio modality. So that's what specifically this is going from away from audio. And when they expected it, it took longer for them to respond than when than when it was split. And so we're seeing that expectancy, if it was something, the way I kind of call it is like sticky. But essentially they expected it and were used to it. And so when they had to switch away from it, it became harder and therefore took longer. Um, and so all of these super in the weed details are really getting at, there's a cost of switching between modalities, and there's several things that we've started to see where it makes it harder for people to switch. So first, if users expect a certain modality, and this is often due to prior experience, and that could be because we told them, or it could be because they felt it just because they noticed like, oh, there's a lot of audio in this. So now I'm thinking it's going to be audio more than visual. So whatever is causing that expectation, it's higher to switch away from something when people are not expecting that change. There's also, kind of along the same lines when they're adjusting to a different sensory input, that adjustment takes extra time. And when there's a clear signal and they have to switch away from a clear signal, there's also a higher cost of switching. And so what do we do with that? Like, how do we take that and make it actionable? Because, this is really low level. I mentioned psychophysics, but how do we take that and apply it into the real world? I think there's a few things that we can do or ways that we can think about it. So thinking about people's expectation, if you're switching, you could cue the new modality to help people accommodate that, help people start to expect something different so they know what's coming. Also, using redundant cues could ease the transition. So when switching to a different sensory input, if you know that you need to switch, you could use both for a couple of seconds or minutes or whatever the time allows, so that people can start to see that they have both and then rely on the new one. And then again, that also could provide or be a form of cue to help people do a better job of switching, have a little easier job switching. And then also, one of the things we were really interested in with this work was that clear signal component. And so you could just simply wait until it's a little bit imperfect. So don't immediately switch when you know something's about to be harder, but actually let the user feel that friction of something not working perfectly and then switching the signal. So kind of now we're going way, way back to like 10,000 feet above all of this. Um, One of the key points I'm making here is that wearable AI fundamentally reshapes interaction and how people are interacting with the world and with technology. Um, and that's because, we can increasingly use wearable technology to sense, infer, and prioritize information, both about the person and for the person. Also, the AI tools, however they're developed, they're actually mediating what information is shown and when and through which modality. And that's significant because it's it's taking the burden, but also the power off of the person, for that information to decide what information to attend to, because it's narrowing it down for them. It's deciding when to show it to them and how to show it to them, and that has impacts. Even just going back to what I was just talking about, you know, showing something versus saying something, or versus an audio cue for a person, that has implications for how quickly they can respond. Ignoring all the other stuff that I was talking about with expectation and things like that, we still know just using one modality versus another, there's different impacts to how people are going to respond to it and how they're capable of responding. Um, and so it's also reshaping in a few other ways, because recall at the beginning of my talk that interaction is continuous, it's not episodic. So it's happening throughout the day, throughout, a work environment, throughout all of the interactions that this person has, as long as they're wearing this technology. Um, and the context of the real world also is competing for attention. So even with these wearable devices and, whatever AI enablement exists as a part of those devices, um, the context of the real world is competing and impacting how people are responding. And so, sometimes that can be really good, but also sometimes that competing means that if the AI that's being used, if that decision about, as it's mediating what information and when and through which modality, if it's not really well done, it can actually cause more conflict and it can cause more competition for attention rather than supporting the person in the ways that they need. Um, and so, through all of this, essentially, like the way that we are adapting, or the way that the technology is adapting, is reshaping how people are thinking. And so there's this fundamental shift then that wearable AI is causing about how people are interacting, not just with the technology, but also with the world. And so kind of my whole point with all of this is that AI is raising the stakes for wearable design. It's making it, both have potential to do more and to be more effective, but it's also really changing how we have to think about it. And that's because we have to consider all of the ways that there's these trickle down effects or ripple effects, which, with each of these decisions, because how it's prioritizing information impacts what information people are processing, and that's happening again over time. It's continuous. It's not going, just one moment to another. Um, and so, kind of going back to the core question, circling back to the beginning of the presentation, I named it because I think a lot of times when we hear about AI, we're thinking about what it can do, and not thinking quite as much about the person themselves. And so, if we have all of this AI enabled capabilities, like, do we still need human centered work, human centered research, human centered understanding? I think more than ever. Um, and that's because it's shaping the interaction, but the human then becomes the bottleneck. Um, and one of the things that, when we're thinking about design decisions, we're often focusing on, or we often learn things that um, come into play, like input accuracy. And so, people are imperfect. And so it's important that we're able to input content into the systems, but we can't always be perfectly accurate. And also the accuracy of the system, if it's not caused by the person, that can impact how they're interacting or how they compensate for system errors. Um, and then also user acceptance comes into play. So we need to be thinking about all of those things. Um, And so, kind of the way I think about it is, the smarter our systems become, the more precisely we have to understand people. Um, and that's because these systems can reshape attention or can reshape how people are attending to information, what information is available. But context is also reshaping their capability. And how we design it is what's where we're really, choosing how we're reshaping what they're thinking about. And in order to do that well, we have to really understand people well because we have to understand the challenges that people um, might have and also what they're really going to need in the moment. And I think that's the last slide that I have. Um,
That's great,
and so,
Dr. Smith. Yeah, thank you.
well,
That was
thank you.
great. That's excellent. Let's jump into some questions. If you have any questions, please feel free to drop them in the Q&A. And I see we have one here up front. We actually have two, but one is too big for the moment. Um, if humans are the bottleneck, when will AI decide to take the bottleneck away? That's just too large for us to touch, I think. How does the response to stimuli change for subjects who are visually impaired, hearing impaired, or dual sensory impaired?
So let me open up with this is not my expertise, or that is not my expertise. So I don't know like the specific details of it, but I am pretty sure that that change would be very different for as people have different visual or hearing or other impairments. And so um, again, this is where I don't have the details of that. I do suspect there is some research on that. Just haven't looked into it. But
Okay.
I would say I think somebody that's visually impaired, that's where like you could almost equate it to the noisy situation where their vision, if it's they still have some but it's impaired, it's imperfect. And so that's already kind of cueing them to rely more heavily on other senses. And so I would just expect to see kind of could almost use that to learn about like how noise might affect what people are doing because they're working in or they're living in a world that already has visual noise or hearing noise when you're using it through the sense of like just imperfection where it's harder to detect signals.
Thank you. Um, Next question. What are the real world examples of issues and risks that keep you awake at night?
That's a great question. Um, and I think I'm going back to this slide because I think what keeps me awake at night and maybe keeps me in a job is that there's so much focus and emphasis on better systems, more advanced AI, using the tools more effectively. And I think that that's really powerful and exciting, and it's flashy and it's usually well funded. But what I think is maybe more important, no, I think it's more important. I don't know that everybody agrees with me, is that understanding of people. I think that it's so um, can be really fun to think about the capabilities of technology and to get excited about that. But I think we're often not thinking enough about what it means for people. And particularly in the environments where like it doesn't perform at optimal values because emerging technology isn't perfect. No technology is perfect, really. And so we also have to think about those failure cases. And I think we don't think about them enough. And when it comes to wearable technology, it makes it even more critical that we understand people really, really deeply in these like really minute ways, but that accumulate throughout a day or throughout a lifetime of interacting with technology.
Okay, thank you. Um, with respect to cueing behaviors or providing user feedback of sort of subtle behaviors that they may not be aware of, let's say, for example, bad posture, static position in a chair, whatever. Would it be more effective to use? Um, well, there's two questions. One is that recognizing that competing for attention can be annoying. So you may want to turn those cues off if they're not done properly, in quotes. But the other is, should you use, would it be more effective to use haptic and auditory or haptic alone or auditory alone. If these aren't very sort of like time sensitive, they're more about it's more about what's more or less annoying to the user that they're willing to sort of integrate into their life and say, I can accept that small buzz in my pocket to let me know that I should stand up from take a break from my chair, for example. Can you speak to
Yeah.
that a little bit?
Yeah, I think this is where what is so interesting about that question is and that problem space is that I think it's very, very individualized and very, very contextual. And like, for example, vibrations to remind you to stand up, maybe as an example. I think most people that I know have had a device that would do that for them, and they have turned it off because it never came at the right time. And what I mean by that is, it came at a cadence that wasn't optimized for what they really needed, either because it was like in a meeting um or it just didn't account for the fact that like they were tired, they had just run, and now it's saying, well, it's been an hour since you moved and you should move again. So this is where I go back to that, like, optimizing for the individual is really hard because every person's different, their context is different, and how they're going to perceive those signals is different. And so I do think that the capability of, those little nudges is kind of what it sounds like you're referring to, can be really beneficial, but not if it comes at the wrong time. And I think we haven't figured out how to make it come at the right time yet. And so I feel like that's where it's failing right now is the idea is good, but it's not perfect enough. It's not precise enough for the people that are using it. That eventually most of them that I know are turning it off.
That makes perfect sense. It's almost like if it was integrated into your calendar, for example, or if you had some
Yeah.
other sensor on your body that gave, you know, particular information that said, yes, in fact, you have been static in that posture for an hour. Maybe, maybe that nudge would be more well received. I don't know, but I mean, how much do you want to let it in? I guess is
Yeah, yeah.
is
And
the
how much would
question,
it need? Because, my
right?
calendar is probably not accurate. Like that's probably it would get it closer, but I bet it still wouldn't be enough.
Yeah.
And that's
Okay.
just a guess. I have no idea.
Understood. Thank you. Okay, let's see. I'm not sure I understand this question, but I'm going to ask you anyway. What is the business model through non-FDA approved wearables? Did I miss that? Did you just touch on that?
So I didn't talk about anything like FDA approval, and I don't know much about that. And so maybe that's a question not for me. So I
Okay,
don't know that I have much to offer there.
understood. Well, let's jump through here. Have you assessed any use cases in which you compare human only, wearable augmented human, collaborative robotic applications, or full robotic automation performance?
Not yet. So I do have some potential collaborations with some other folks that would be along those lines, but I haven't started them yet. But I do think that's where, really we need to be figuring out how do we collaborate? How do we take advantage of what AI can offer, what wearables can offer by being really close to the person and on the body? Um, and then like where is the line where it stops being useful and where is the line where collaborating with the person is better? So I think those are really good questions. It would be really hard to address all of that in a single career. Even I think there's so much work to be done. We're really at the beginning.
Okay, great. Next question. We know that visual cues such as a safety sign or a poster on the wall are often eventually overlooked because they've become part of the background, in quotes. How do we foresee wearers not becoming desensitized to an AR overlay in the same way?
Oh, I love this question. And I thank you for using AR overlay. You have used it well, using that terminology. So for an AR overlay specifically, a key benefit of it is it's in front of your face and it is hard to ignore. So we know that, motion onset can cause people to, it can draw their attention. And so if you can make a display that has the appearance of motion onset, it could actually like pretty reliably draw their attention. I'm not sure of how much work has been done on like that particular question, but I'm pretty sure that's something like it's hard for people to ignore. Um, And also, if it's an overlay, then it's going to block what's behind it. And so, actually, like if you're looking behind it and it pops into view, it's occluding your vision. And so, maybe you adapt and look around it, but it will be harder to do that than to look at it. Now, this is where, depending on how it's used, if it's overused and there's lots of pop ups and things that are not relevant or not interesting, then I could imagine that people would try to work around that. Or, if it's bad enough, they'll just stop using the device, the wearable. Um, but I do think it's a little more, thinking about safety in particular, it's a little more salient than um, a poster in the wall or something else like that, because it does have or it could have apparent motion, and it does or has the capability to block what's behind it.
Gotcha. Okay, on to the next one. This one says AI is currently basically overused in Australia to the point, in a reductionist summarizing manner, to the point of missing some information by culling. Do you perceive a similar challenge with augmented reality?
I think maybe. I guess that's a non-specific answer, but the reason I say maybe is there's limited amount of space, there's limited amount of ways to give content to people. And so if you're trying to convey a lot of content really efficiently, then you know shortening that to put it on in an AR format, or an AR overlay format on somebody's glasses, you may have to shorten it, and it may be this reductionist kind of summarizing approach that you're referring to. um, but I guess I think of it in a very different way. And so I think like AI, when you talk about AI as like a summarizing approach, that's where I think of like LLMs. And from like AR and how that would intersect in AR, I think of it a little more as um almost like deciding what to emphasize. And so it's not necessarily reductionist or summarizing, but it's really directing like what's emphasized. And so I think instead of missing information by culling, it's missing information by just never getting it or never seeing it because it's not emphasized, it's not selected. So I think it may have different downfalls and kind of how it winds up being used together. Um, but I think that's all in the design. And I think what goes on AR glasses is still a open question.
Okay, great. And our last question, I think, here is since the interaction is continuous, how can you imagine defining the success of using it since you don't know a situation in which it is not present?
Oh, I really like this question. I always think about it from different perspectives, because there's the perspective of the person that's using it. Like, did they have an enjoyable experience? Are they satisfied? Did they do what they needed to do? And were they safe enough while they were doing it? Those are actually three different things that don't always have the same outcome, because sometimes I am safe, but I'm annoyed because it's not letting me do something I want to do, Um, Even thinking about like some devices would block texting and driving, and I don't think they do anymore. And it's because I think people probably got really annoyed at it blocking them doing what they wanted to do, even though it was trying to promote safety. Um, and so I think there's that tension between, safety and performance and experience. And so when measuring that, because I think you mentioned, how do we evaluate that? I think we have to always consider it from multiple perspectives. Um, and so right now we have a world where you can, A B compare with and without the technology. Like it's not so pervasive that it's
Mhm.
unavoidable. But I think if it was, you could look at, like how are they performing? Like let's measure performance. Is that, response time and accuracy, or error handling? But also what's their experience?
Yeah.
Because even if it's making them better, if they're really annoyed, eventually they're going to stop using it. And so you don't want something that makes people perform optimally, but they hate it, because then they're not going to use it, and so they're not going to perform optimally. So I think trying to measure, both like some things that are more objective and things that are more subjective to capture not just what they do, but also how they feel about it.
Nice. Thank you. Great answer. Okay, we are back at the top of the hour, so we're out of time. I just want to say thank you very much for your presentation. It was excellent. And to our attendees, you can register for our upcoming events at coeh.berkeley.edu. You can also subscribe to our YouTube channel, where you can find recordings of previous webinars and other events. As a reminder, if you logged in today with your registration email, you will receive a link to the evaluation form, and that will qualify you for a certificate of completion worth one continuing education contact hour. If you have any questions for us here at COEH Northern California, you can drop us a line at coehce@berkeley.edu. That's coehce@berkeley.edu. Thank you again to our presenter, and thank you all for attending. And I look forward to seeing you all at the next one. Bye now.